let's finish 3. Let's go back through and catch what we didn't do in 3. Thursday, you don't have class. And are there any questions before us start? I think we pretty well covered the whole chapter anyway. Make sure you do know how the models basically work. Realize when you're looking at the models that as something travels from one end to the other end, it's going to pass through routers along the way. And it's going to go up to layer 3 when it goes through the router. That when the router sees that it's got, when it's the IP address for that router, that it will have traveled up to layer 3. Goes through any switches, it goes up to layer 2. Switch looks at it and says it belongs on whichever port. But when it goes through routers, which is really what it's going to travel across, it goes across the internet. Each time it gets to a router, it decapsulates that packet data unit up to layer 3, looks at the IP address on it. Remember, it's got to encapsulate it to be able to find the IP address, because that's been encapsulated when it made it into a frame. Looks at it, decides where does it belong. Looks at it and knows, okay, I know where it's supposed to be going to. So then it encapsulates it again, puts the new MAC address on it of where's the next stop. Because the IP address is going to give you the ultimate destination. A MAC address just gives you the address to the next location. Does everybody follow on that? It's just like you mailed a letter. The address you put on the envelope is like the IP address. Okay? The bins that the post office keeps switching it from as it goes from post office to post office is like the MAC address. Okay? That keeps changing, just tells it which regional center does it go to next. It just keeps pointing it to the next location along the way until it points to the ultimate location. Each of the places going from router to router is going to be a hop. And you're usually going to see that drawn as that, as a curve going up. It looks like a rapid hop. Okay? But that will be that we did it one hop to get to the next router. So if to get to the ultimate end, that if it started from here and this is where it's going to, it involves 3 hops. Does everybody follow on that? And that's going to be the wording you're going to see on that. It's going to be how many hops are you doing? Now, obviously you're passing through 4 routers on the way, but there's only 3 hops involved. So you're hopping from router to router. And getting to the first router is not a hop. But on each one of these routers, it's going to go up to layer 3 and come back down. Up to layer 3 and come back down. And when it finally gets to the PC it belongs on down here, all the way up to the left. Just like it came all the way down. there, but here only goes to 3. I just told you wrong. It's not layer 3. Yeah, it is layer 3. No. So layer 3 on each of them. Does everybody follow on that? So, got 7 layers, but it does not always go up to the top layer at the intermediary stops. Okay? The other part is with those 7 layers, effectively, layer 1 is talking to layer 1. Layer 2 effectively is talking to layer 2. Y'all follow on that? Because what layer 1 saw here should be identically the same thing layer 1 will see here. Okay? So, it's not actual conversation at layer 1, but layer 1 to layer 1 should see the same thing. Okay? Now, in terms of layer 3 here, it's just going to see, it's actually going to stay the same, but layer 2 is going to change all the way across there. But layer 2 and 1 will keep changing on these, but layer 3, so it doesn't change it at that point, it just looks at it and passes it back there. So, all of these, layer 3 should be seeing the same thing. Now, layer 2 is going to see something different because it does change information here, 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 and here. What's on layer 2? Because the physical address changes because when it left here, it pointed to here. Physical address told it to come to this route, to that gateway community. When it left here, this one, the MAC address is pointing here. IP address is still pointing here. Okay? The IP addresses aren't going to change. Where the source was, IP address stays here. When it gets to here and goes to send it to here, the source MAC address changes, being this one, and this is the destination. Everybody follow that? Come on, that's working on that. Any other questions on the general idea of the, or any questions on the models, the TCP, IP, and the OSI? And say, get the concept of how they're working, of what it is and what the 7 and 4 layers are. But as far as the details of what's working in there, we're going to look at that chapter by chapter. So exactly what it really does all do on layer 3. We're going to look at that when we get to chapter 6 and 7. Maybe 6, 7, and 8. Okay? When we get in the next chapter, that we're going to start looking at a specific layer and look at the details of what happens within that layer.
This might be what we're going to talk about next time, but I mean,
Okay.
It's always got to keep the source address, IP address, and the destination address all the way through the packer. It wouldn't know where to come back, right? But then as it gets to each router, it says, okay, to get to this destination, my shortest path is to this guy, so he's going to throw like another address on to get it to the next router. He's going to look at it and say,
The packet is going to stay the same. The frame is going to change.
and the frame's where, like when it tells it
And
to go
the
to the next.
frame has got the MAC addresses on it, and that changes. Because the frame, remember, put the physical address on, which is the MAC address, and that just tells it what's the next destination on the left. The IP address is going to tell it what's the ultimate destination and also what the ultimate source was. Okay? Does that answer? So they're playing two different missions there. Okay? The IP one is where are we ultimately going to and where did we really start out at? The MAC addresses just tells us on the current segment what we did. Okay? Where did we just come from and where are we going to immediately? So if we're doing that cross-country trip, MAC address tells us which town did we start in this morning and where we're going to stop at for lunch. And then when we stop at lunch, it changes to where did we stop at lunch as the source to where we're going to stop for supper. Where the IP address would be where did we start this whole trip from and where are we trying to get to.
Does your router, like say my home router, will it have the information to get to the destination, or does it say, okay, I've got this destination address? Does it have like a whole table in my router? Does it have that much memory? Does it go out and say, ask this guy, hey, I got this address, where do I go?
It keeps a table in there, and even your PC keeps a table in there, okay? It keeps a host table. And it's going to know to get to certain addresses, here's how to go. But it keeps the second thing in there. So you got default gateway, which says, if I don't know where that IP address is, here's where I'll go to. Okay? And the MAC's going to work the same way on that. Go to here if I don't know how to ultimately get to where I'm going.
I mean, is that the same thing happens on the, like, what if it gets like the second router and it's like, hey, I'm not real sure where to go? Does it have like a default gateway also?
Every one of these has got a default gateway, and that's actually what they're going to all work off of, because all this PC is going to remember. It doesn't know what the MAC address really is for over here, but it does know, coming out of it, that it does know on some that it says it belongs to here. In other cases, it doesn't know to go, because it could have multiple routers connected to it.
Oh, yeah.
Okay? Within that network, and it's which one does it go? Or when it gets to this router is going to have at least 2 routes off of it. So it's got to have a routing table to know, okay, which way to send. And if it knows which way to send, because some things it will, if it's sent there before, it will remember where it's sent to, okay? If it doesn't know, it's going to go out and search to find, but if it can't find it, it's going to go to whichever one it's designated as the default route. Now, it does mean it can, if it's not careful, and there's advanced techniques will do to get around this. It could get in a circle, but it does, there's techniques you set up on the routers to stop that from happening. So that it knows that, no, don't go that way, because I already been tried that way, route on. That doesn't sit there. The other part is they're timed out there. And the way it times it, there's several different ways. But it will only stay out there so long, and if it doesn't get there, it gives up. The one that is most often used is in terms of hops. It's that they're in that. Usually now the default number of hops, and you actually put it on a packet when you send it out, and you tell it what's the maximum number of hops. 31 is the default, if I'm remembering right. Currently, it used to be 15, and now it's 31. And that if it takes, every time it goes through a device, it's going to subtract 1 off how many more hops it can go through. When it gets to the point where there's no more hops it can go through, it just dies. So that stuff doesn't stay out there forever, eating up all our bandwidth. And really, except for once you get inside a network, you should be able to get to the network it belongs on in less than 15 hops to anywhere in the world. They had to up the count of what the number is now, because once you get inside the network, there may be a number of routers it's got to pass through to get through the correct subnet. but you can be on any network on the internet less than 15 times. If it takes more than that to get to the network, then it's an unknown network. It doesn't know how to get there, or something's set up wrong somewhere. So it needs to die because it's been out there too long. But the default gateway is going to be extremely important too. That's how a lot of traffic is going to travel, is via the default gateway. Doesn't know how to get there, so it takes its default out, and then ultimately it's going to hit a device that says, okay, I know where that is because it's attached to me, or it's attached to a router that's attached to me. And their tables are going to remember everything that's attached to them, plus depending on whichever protocol you're using, could be one or two layers beyond that it knows about. Now, the other part is you can build it into that table in any one of these that tells it, besides it having learned the way to go to get something, you can also put it in the table and therefore to tell it this is the way to go. Which is the way it used to be. Now static entries are not used much. They're going to generally just be used within a network, not referencing stuff outside the network. But if you go back prior to the early 90s, DNS and everything else along there, that had to all be built into the table there to tell it how to go find anything, because it couldn't just think on its own. So the network's much more intelligent. Everybody got that? Also, while I'm thinking of it, no class Thursday. Pretty sure I've told y'all I've got to send a note out too. I will be here tomorrow, those of you that have me tomorrow, but I won't be here Thursday. And I've got a meeting in Macon. But with the days I've already missed and the days I'm going to miss, I'm going to stay around tomorrow to make all my 3 classes tomorrow. But encapsulation is just where we're taking what we already know and putting more information around it. Okay? It's just like a medicine capsule. What is it? You got a little wrapper around all those little pieces of medicine inside it, right? It's encapsulated. Decapsulating is when we take the capsule off. When we take it apart, take the wrapper off. Do make sure you do remember segments. Packets, frames. Here's the confusing part. Those are all PDUs, or packet data units. Notice we've got repetition of names there to confuse you. So make sure you know, are they talking packet data units or packets? Okay? Two separate. Packet data units is just how we split the information up and deal with it going through the network. Packets is what we're doing on layer 3. So that was layer 3, it's layer 2, and layer 4. Segments, all we're doing is just breaking the information up into manageable sizes. We're also numbering it at that point, okay? So you got to number the segments so we can put them back together correctly. Packets, we're taking that segment and encapsulating it, and adding on there the logical or IP addresses, plus a number of other items of information. Okay? size of it, some error checking, some other things will also occur there. Also, so that can all occur there. It can also actually be encrypted, but this can actually be encrypted above there too. So the data couldn't have been encrypted before it was even gotten to you. Frames are taking that packet and encapsulating it and putting the MAC or physical addresses on there. Okay? And again, some other type information for error checking, etc. So that we can know that it got here. So keep those 4 terms all straight.
You know, I think in the book they call it a protocol name.
Yeah.
That's something different.
And I like that one better, but you'll see, I wasn't sure which way. One of the other books of theirs called them packet data units.
I wonder if they changed it because it was so confusing.
It's used both ways out there in the world. And I say they used to actually call it in the Cisco books, packet data units, and then they went to protocol data units for a little while, but they've got that back as that now. That's good. But you could see it when you're reading other stuff as a packet data unit instead of a protocol data unit. I like protocol data unit a whole lot better because then you don't have the confusion of names there. Because sometimes when I've taken some certification tests, I've sat there and read the question and it said packet, and I'm reading it and I'm going, you really don't mean packet right here. Because obviously we're talking in generic sense. And I'm going, this is a bad question because you said, and that's what some people will do out there is talking to PDUs say packet, when they should be saying packet data unit or a PDU. And confuse things totally. So keep those all straight, keep their layers on there. Remember we said, as far as devices, that we had hubs and our NICs here, network interface card, which is the card that's in your machine, which may be built on a motherboard, okay? Whatever, however your machine actually accesses the network, which could be your wireless card, wired card. It used to be separate physical, separate cards. Now it's built in motherboard a lot of times. And hubs are on this layer too, although you really don't have hubs. Actually, a bridge will fall there too, but you don't have bridges anymore either. Okay. Switches are going to be on this layer, and your NICs quite often are considered on that layer also. So that the switch is sitting on the logical link sublayer, and the NIC is sitting on the MAC sublayer. What device do we have on layer 3? What have I been talking about this morning?
Routers.
Routers. Okay? So those are the devices on the layers. The other one down here is the media itself. On layer 1. But keep switches and routers on their layers, although you can have layer 3 switches that actually work layer 2 on layer 3 that got the router as part of the switch. Okay? You'll see those as routers as the old term, but now they're the ring switches. And you actually do have routers that, so you've got some devices that play both ways. Instead of being distinct, it would be different ones always. So if you see a layer 3 switch, yes, that is real. It's a switch that works layer 2 and layer 3. The switch itself is going to work layer 2, but a layer 3 switch also has a layer 3 functionality. Now, the router is going to give you more functionality than a layer 3 switch can do. It gives you the basic functionality. So you will see those out there. So if you're reading along and you read something about a layer 3 switch and you go, wait a minute, Dr. Watt said switches are on layer 2, how could this be? They've just built additional functionality into it. So do know those 3 things also. Application layer, remember the application is not on the application layer. The application layer passes the information to and from the application. Presentation layer gets it in a format, either gets it into the format when we're going back up that the application is going to work with it, or it takes the application's information and gets it into a format for the network to work with. And the session layer just establishes the session between the two nodes and maintains that session. In some cases, it really does do the maintaining. In some cases, it doesn't. It just establishes it and lets it go. But on some protocols, like UDP, we're just going to throw the information out there, or TFTP. We're going to throw it out there and assume somebody catches it. TCP and FTP are going to require verification that actually is received. Some things you can lose stuff on, and speed is your primary importance. Voice over IP, VoIP, is going to use UDP. If it loses part of this information as it sends it across, that's not a big problem, because it can lose fractions of our words as we send, and we can still understand it. But we don't have to have every little piece of it. If we tried to do it where it verified it actually received it, it would make the phone call use a whole lot more bandwidth and slow it down. So in that case, with voice over IP, it's the responsibility of the receiver to make sure that they got everything, that they heard everything. If they didn't, you just tell the person calling you, repeat that. The call just broke up or something. And you didn't fully understand it. And we all do that on phone calls. Anyway, so doing that when it goes to using voice over IP to make our phone calls is no problem to us. And now that we're all doing cell calls, we obviously do that a bunch of times. Because after all, can you hear me? The guy just made bunches of money off that one. And every one of us has said that a bunch of times. All right, questions on all of that? Protocols, let's glance through those again real quick, since we've got some time here. And remember, a protocol is just the rules of how it's going to communicate. It's not the communication, it's just the rules of knowing how both ends are communicating with each other. You got protocols in real life too, remember, okay? You got laws out there that say you have to do certain things. So the law says on the highway, we've got to drive on the right side of the road here in the U.S., okay? Go to other countries and they drive on the other side of the road. That's a law, okay? Walking down the hall, you tend to walk to the right side of the hall, correct? You don't have to, There's not a law that says you have to walk on the right side of the wall of the hall. But it makes travel through the hall work a whole lot more efficient generally, right? Because if you get on the other side of the hall, then you start blocking other people and stuff. That's protocol. Protocol says how we behave around certain people. Okay? Not a law on it, but it's a protocol and a generally accepted way that we know to communicate. So, we've got lots of protocols that affect us also. And some things are more formal protocols, and some things are less formal protocols on as far as general life. So you've got a number of these, and so on the computer, for the two ends to communicate, they've got to both be using the same protocol so that they can understand each other, so that the receiving end knows what it is the sending end's trying to send. So if they don't both use the same protocol, it's a whole different thing. I think I pretty well went through the list of them for you that they have in the book here. We'll come back and talk about them some later. They show you layers that they go on to. And so I think I told you all of those. And that we'll actually come back and talk about those in the various chapters and throw some more protocols out there as we go along the way too. So those are the ones. And most people don't realize they're using all those protocols. That you use one or two, maybe, but it's really using a number of protocols to send the information when you're doing anything there sitting on the internet, so that they're all in use on you. And so it's going to use a number of protocols just to send the message across. All right, questions?
We'll probably get into this later, but so the UDP is like YouTube, right? If you go and start watching YouTube, it's just going to send it out. If you get it, great. If you don't, great. But what if I just leave that web page? It doesn't keep sending to me. Somehow it knows. Is that where the session comes in? The session says, well, it's been broken, stop sending to them?
Because at that point it knows not to send anymore. Because you're actually still in that case, because actually sitting there on web pages, you're actually telling it to send you more information. So as it sends on that you're asking for more. And that actually you established, in the case of the YouTube, you established a stream coming across to you. And so when you go close that page on there, you've told it, cut that. You've sent a message saying, cut it off. Now, if you just put it in the background, obviously it keeps on sending it. And so you got activity still going there. And that we'll look at later also when we talk about, in terms of on TCP, we'll talk about how it establishes its conversation and then how it disconnects its conversation. So we're going to talk about a three-way handshake when we get there. But UDP, we requested it, sends it. We don't send back saying we got it or not, but if we need more, we'll tell it we need more stuff coming at us. But when it's sending across that video, it's going to be letting us know. Okay, other questions? No other questions? Well, I look forward to transferring hundreds from Cisco to Blackboard for this test for all of y'all. And I do need to start doing that soon, but I haven't had a chance to start transferring grades back and forth. If you have not given me the permission form yet, but I think all of y'all have, make sure you get it to me. And that's one thing I've sort of held off on transferring, because I know the online class, I'm still missing a couple in there. And when I go to transfer grades, I'll transfer in both classes, because it's 2 separate classes in Blackboard, but out there at Cisco, I've got it all in one class. Cisco thinks I teach a bunch anyway, and I don't split it up into multiple classes on them. It makes it easier management for me, because when I go to activate tests, I only have to activate one time. If I put y'all in separate classes, I got to activate more than one. But I can, as I transfer, that I'll sit there and look. I don't think I've transferred grades, but yet.
I don't think so. Last I checked. Now, okay, so on the application layer, the actual application is not the same as the application. Like your browser
Correct.
is not the
The
application.
application itself is not the application layer. It's separate.
So, but when you have like a browser going and it says, okay, I want to make a request, and I guess when you set up your network, there's just software that runs in the background the whole time to intercept something and say, hey, I'm going to start this ball rolling.
When you go to send, when you hit send there in your browser, at that point it transfers it over to your network program. Your network program takes over at that point, which is part of Windows or Linux or whatever. If you don't have that network program set up in there, nothing happens at that point. Because you can have a browser and not be connected to
the
a
browser
network.
try to find it and it says, hey, there's no network.
It's gonna, you hit send, and then after a minute or two, depending on whatever the time delay is built into it, the browser's gonna say, wait a minute, I've never gotten anything back. And you're gonna get a 404 error at that point, a page not found.
So all this kind of starts when you get on your computer, and of course, first thing you gotta do is set up a network. Nowadays, it just finds it all automatically pretty much, but that's built, I guess, into operating. So that's what kind of gets the whole thing started, is you set up your network and it says, okay, now I can do what I need to do.
And that it's got a program that actually sits there as part of your operating system that links between the network program and your applications. So your applications, and actually that's where you've seen APIs. This got an application program interface that connects the program to the network program that runs in the background. Okay? And it uses an API to do that. And that's part of the operating system. That API is not there, it's not going to be able to connect to the network. Otherwise, your program's going to still work fine, it's just not going to be able to do anything from the network, it just can't connect there. And sometimes when it's not, it'll tell you that you've got an API. If you were programming the program, you've got to build into the program, because you want it to connect to the network, you've got to build in that API to be used. So that's got to be written into your program to be able to connect to the network. Then you've got to have the link to the API. All right, any other questions? If not, I will let y'all go, but we still got in 45 minutes today. But we ran through the stuff last Thursday when I was thinking we only had 1 week instead of 2 weeks until I caught on. But the other part is that in terms of that one, that if you do want to go back and listen again and listen to me talk differently a little bit about it on the 2 different reference models, on the 2 different models there is video out there from back in 2004 or whatever, sitting there in Blackboard for you, of a video about the 2 models. But I've got that there sitting in chapter 3 for you, which is actually out of YouTube. And it's actual video where you're actually watching me work off the board like you sat in class doing. we set up a camera in the back of the room and filmed me up there. And hopefully, soon, that we may be able to do the same thing again here. That once I get my new laptop, I'm going to see if we can start videoing using the laptop with my camera. My little camera that belongs on with the computer sitting on there, not the laptop camera, because the laptop cameras generally aren't good, although I'll see how good that one is. But I know my home laptop has got a horrible camera on it. But I've got a little external camera sitting on my computer at the other office, because I've recorded some stuff from the desktop there before. And so that may well work for us. I'll wait and see. If it does, we'll start setting the camera up, the laptop in the back of the room, and video away. I am a little bit slow at the moment on getting the lectures out there. Hopefully I'll get the audio out there tonight, but I still got one video from yesterday to still make and put out there. As I got more caught up last night to it, but I still came up short one when I called it a night, because all I did after I got home yesterday afternoon at 5 o'clock until close to 9 o'clock, except for eating supper in the midst of there, was sat there and worked on videos and did a couple other little things to classes. Those of you that are in 1305, is that both of y'all? You're in 1305. I did put a sample out there of modules that I did this morning. I just stuck out there, but I figured that one out, and I'll show you tomorrow in class about how to do modules in Boca. Okay? That's what I've been working on this morning, and also remember that I had to get a hotel reservation for tomorrow night. Either that or to be down there in Macon at 9 o'clock in the morning, leave up here at 2 o'clock, 3 o'clock or something odd in the morning, and manage to eat breakfast all the way and fight traffic. The school said I could stay down there. So after class tomorrow, after I have his class tomorrow, I'll hopefully head on out onto the road at that point, or maybe a little later or something. Probably a little later. Actually, I'll run dead into rush hour in Atlanta at that point. So that's the other part. Now, unless I decide to go via Rome. I actually did that last time I went down that way. A few weeks ago, then I went down to Rome, to Carrollton, and then across to Griffin. And got me around Atlanta at one point. It's a little bit further, but it really didn't take any more time. And I didn't have the aggravation of sitting through Atlanta traffic. So I was in Rome that Friday anyway, and I was going to go south, and I was going, might as well, since I'm sitting in Rome right here, go ahead and try this other way. All right, then I will see y'all next Tuesday. Make sure you take the test. There's not a lab in 3, is there? Or is there?
On 3, there's that thing where you said you want us to comment on
There's discussion board in 3.
discussion board.
I don't think there's a lab, is there?
I think it's just the discussion board.
I think it's just discussion board. Make sure you do the discussion board. If there's not 2 other people post it yet, make sure you get your post out there, so that then we've got 2 posts, and then that y'all can start answering back and forth. Okay? Because I have a hard time in the online classes persuading students that really do need to post discussions earlier than at the last minute. There's ones that try to work on ahead, they can't. They'll make their post, and I'll have 1 or 2 students write and go, I can't reply to 2 different people because there's not 2 posts out there yet. And I'm going, well, you're just going to have to wait Try again as it gets closer. Somebody else will ultimately post.